Okay, one more point. Sometimes it is much more convenient for us to write a small function and use it for post-processing or any other applications we have. Usually those functions are going to be general functions. Whenever we need, we just call them. So let's write one function, for example, here. And I'm going to call it output. And this function is going to get displacement and stiffness matrix. What else? Number of nodes, and also prescribed degree of freedom, which was the boundary conditions. So this matrix is going to get this information. This function is going to get this information. Oh, I forget to write the function here. Function. Output FEM, for example. And I can say, for example, display displacements why I use this. Okay, so basically this display displacement, and then under displacement let's define a parameter which is going to write 1 to number of nodes. So 1 to 4. And format it as like this. This GG, transpose it to make it a column. And then beside it, show me displacements here. So it is going to be have a nice presentation like that. 1, 2, 3, 4, and displacement of the 1, 2, 3, 4 number nodes of 1, 2, 3, 4 in front of it. And I can do the same for forces, reaction forces. So I haven't calculated the reaction force. So force is stiffness. Let's copy. Otherwise, I'm going to make mistake. Stiffness times displacement is going to be forces. And that's it. I can say, because I know the node 2 force is going to be 10, it's given, I can say just give me the prescribed or boundary condition forces, which they are the ones with fixed support. So reaction forces is going to be equal force of just the prescribed ones. I don't want to show me all of them, because node 2 force is 10, we know that. And display, again, reactions. And write it down like this. The prescribed node, which is going to be 1, 3, 4, and in front of it, reactions. Copy. reactions. So let's save this. So this is our function. I'm going back to my original code, and here I can call the function out. I copied it. Output FEM, and this is displacement. The next one is stiffness. Then the number of nodes, and finally the prescribed or boundary conditions, prescribed nodes. So if I call it, I expect to see some nicer presentations. Okay, let's see what is the problem here. Let's debug it. Okay, here I made a mistake. When I'm passing the functions, I made a mistake, element nodes instead of number of nodes. So it should be element nodes. Now everything, the size of displacement and GGs, they're going to be same. Okay, now let's run it. As you can see here, now we have nicer presentation. It write displacement 1, 2, 3, 4, and then the values of them. For 1, 3, and 4, it's 0 displacement, and for node 2 we have something. For reactions, we have 3.3, the negative, and for 1, 3, and 4, and for the node 2, we already know